Hello, everybody. My name is Ted Stewart. Today's webinar is on the Site Safety Index and the impact it has on failure rates and PFD averages. Like I said, my name is Ted Stewart. I am the Program Development and Compliance Manager here at Exida. I help manage the OEM product certification. I assist the end user business, manage the C2C program, and I'm also the Deputy Quality Manager. Yes, I do wear a lot of different hats. And it's all part of the fun here at Exida that we have. You can see there on the screen in front of you that the areas of expertise include safety and high availability automation, manufacturing, and lean process improvement. And once again, thank you so much, everybody, for joining the webinar today. Let's get this going. I do see a few newcomers, so let me go through these initial slides here. The Exida offices seem to be popping up all over the world every year. It feels like we open up 2 new offices. As you see, Exida Japan is one of the new ones. Abu Dhabi is another one that is a new one as well. And so it's very exciting here at Exida. We are a global company, and every year you're going to see more and more red dots. So Exida is involved with the complete supply chain of functional safety in multiple industry sectors. It goes anywhere from the original equipment manufacturers who require the product certification, and it goes all the way through to the end users that actually use the products. Exida provides software tools. We have trainings where basically globally we have one training somewhere in the world every single week. We have end user consulting and procedures that also relate to functional safety, whether it's security, reliability, alarm management, etc. We do have a suite of products and services, and I'll go through these quickly, and then we'll begin today's presentation. You'll see here we have a consulting branch for our end users, whether that's in IEC 61511, 62061, or even automotive, which is 26262. You'll see alarm management and then also cybersecurity. We then have engineering tools that we are very proud of, and that is where this webinar is because of that. These software is where this webinar is coming from. Excellentia is one of the top software programs in the world. You will see that many people globally are using this product, and there's a great reason why. And today's just another reason as to why they're using that tool, and that is because of the Site Safety Index. We also have product certification, which is one of the meats of our organization, where we certify different products. We also have training. Like I said, we have one training globally across the world every single week. We publish probably the most reference materials out there, and it's solely because we as Exida, this is all we do. We deal with functional safety, cybersecurity, and alarm management. Many of our other certifying bodies out there, they have a plethora of things that they do, but because we focus solely in this realm, this is why all of our investments that we have, we reinvest any gain that we gain from the company back into the data to make this a better company and to make our end users, give our end users a better job, a better understanding of what's going on. We also have the product certification, which is the CFSC and CFSP, and newly added are the CACE and CACS, which are certifications in cybersecurity. So before I get started, I'd like to do a quick poll. So if you don't mind, quickly go to your computer. If you just listen remotely, I want to just throw this poll question up and just kind of see where people stand. All right. So here it goes. And the first question is: in your experience, has a failure rate for a specific or for a product differed from site to site? And if you don't mind, go ahead and select one of the two. Thank you. A lot of you guys are already voting. If you don't mind, I'll just give it another second. So that is the question. From your experience, if you have the same product and you have it at different sites, do you see different failure rates for those sites? Okay, and thank you for all those who have answered. That is kind of what we thought as well. 85% of the people said yes, so that's normally what we see. Okay, so that's great. Let me move on here then. Let me close the poll. Great. Okay, here we go. So failure rate, the difference from site to site, excuse me, a number of field failure studies have shown that the failure rate for identical modules in the same industry application have indicated there is a difference in failure rates for the same product from site to site, as the majority of you had said. Typically, the ratio is averaged between 1.2 and 3 times the difference depending on the product type. And I can just share a quick story. We actually just had, because the site safety index is becoming an increasing demand, we did one, and what we found out were the same exact product, 2 different sites, same company, they had the same setup, and there was a 2x difference in failure rates. In this situation, it was solely because of the operators that they had in place. Some people read the document one way, the other person read those documents and procedures a different way, and it created a huge difference. And because of this audit, they were able to find that and help reduce the failures that they were seeing at that specific plant. But why is it happening? Okay, site audits have shown many differences in how things are done from site to site. This impacts many variables in the safety instrumented system, and frankly, you know, when somebody wants to get a SIL certified product or a system, just achieving that SIL rating, what people are finding out, it's not enough, right? How good is a SIL rated product if procedures aren't being followed? And that's kind of what we're going to go through and talk about today. So what is the impact? A key metric for process industries designs is called the average probability of failure on demand, the PFDavg. Many of you have heard of that. After several studies of many field failure and proof test reports, several variables have been identified as keys to a realistic PFDavg calculation. All right, and I put that asterisk there under several variables because there is a white paper on this topic. If you choose to read it, it's a good read. You see the at the bottom, it's called the key variables needed for a PFD calculation. There's a link there, so if you ever want to go visit it, you'll get these slides anyways, and you can go ahead and get that paper. And I see here questions are starting to come in. I'm going to hold questions until the end. I'll answer every single one of them. So just hang in there tight if you don't mind. So the PFDavg, there's 9 key variables. We're not talking about all 9 today. However, I just want everyone to know which ones there are. So the first one is the failure rates of each product, including the failure modes and any diagnostic coverage from automatic diagnostics. Okay. The second one is mission time. You have proof test intervals, proof test effectiveness, proof test duration, mean time to restore, probability of initial failure, site safety index, and then of course redundancy of devices including common cause failures. All right, so how many key variables are impacted by site practices? Okay, well the first one you see here, failure rates of each product. That's one of them. We'll talk about that. We'll talk about the actual proof test interval. We'll talk about actual proof test effectiveness. We'll talk about actual mean time to restore, and finally we'll talk about the probability of initial failure. Now the site safety index model, it accounts for the differences between the targets used during a conventional calculation and the reality of a site due to the impact of operational processes. And like I said before, it's one thing to get a SIL rated product, it's another to see how that plant operates. You know, is that document clearly identified? Do people know what they're doing? You know, is that operator having a bad day? How often do you do your proof test? And like I said, we'll get more into this, but it's just more of a reality thing, bringing this to light that people aren't thinking about. So why is this important? Well, the key variables in a PFD calculation are impacted by site operational practices. Okay, so what can we gain? Well, a model can now show this impact. It could be used to show the benefit of improved operational processes. The life cycle cost comparisons can be done now to justify improved operational processes as well. And like we said before, all the major corporations are now starting to come to us for this reason, because as safety evolves and as more people know what SIL certification is, and they're seeing the benefits that they're gaining, they're still asking, well, I'm not seeing the results I thought I'd be seeing, and that's because, and I think we may be the only certification body currently that's doing this now, but we're going beyond the SIL rating. We don't give you just a SIL rating. We don't just give you a PFDavg. We're now going to go beyond there and help the end users and help their sites become safer. And when you have a safer site, you can now start taking credit for doing these types of things, these types of improvements. Or you'll lose credit if you're not following let's call it the directions. So the Site Safety Index, which is trademarked here with exida, it's a model that is a simple approach based on concepts from the IEC 61508 standard to more accurately account for the site-specific operational practices. This approach allows a site with a strong safety process to take credit for the accomplishment while not masking sites or not masking issues at other sites. Now, what used to be done in the past, and what we because we have our advisory board and we're learning more and more with all of these meetings that we're holding with them. What was not recently, but what was previously stated were that, exida, what we would do is we would take your failure rates and then we make them a little more pessimistic because we knew that our sites weren't all acting the same and we knew there was an issue with this other site. So we decided to dilute the failure rate or to make it a worse failure rate because we knew there was other things going on. And so what we decided to tell them is, look, you don't want to mask issues at other sites. What you want to do is take credit where it's deserved. Okay, and that's what this is coming up, and this is why this is starting to snowball, and more and more people are looking to do a site safety index model. So what is the safe site, and what is the chart that you can see here? Well, as you see here in front of you, there's 5 levels of a site safety index from Excellentia. Okay, and I'm going to read through them because get ready, we're going to do another poll, and I'd like to see where people say things are. Okay, and the first one is SSI 4, 100%, meaning, look, I'm perfect. The repairs are always done correctly. Testing is always done. It's always on schedule. Equipment is always replaced before end of useful life. Perfect world. Okay. Then we have SSI 3, which is almost perfect. Maybe you're probably doing something in the nuclear realm. You're doing something where you have to be perfect. You have to be SSI 4 or have to be SSI 3. And what does that mean? That means repairs are correctly performed. Testing is done correctly. It's all on schedule. Equipment is replaced before end of useful life. Okay, now we're going to go to SSI 2. Still good, Repairs are correctly performed. Testing is done correctly. It's mostly on schedule. Most equipment is replaced before end of useful life. Sure, you might have a few items you don't use all the time, so they kind of fall off the radar. No big deal, right? Depending on the application, it could be a big deal. Then you have medium. Repairs are, they're often correctly performed. Testing is done and mostly on schedule. Some equipment is replaced before the end of useful life. And I usually see some of these in plants where they don't have to be perfect. So they let these areas slack because they focus their efforts in other areas. And then you also, we do run into these companies where you have an SSI of 0, where it's almost non-existent. Repairs aren't performed, testing is not done, equipment is not replaced, etc. All right, so the next poll. And this is, I just am curious to see where things lie. So here's the question. Think of a specific site, okay? Now, what is your estimate of the SSI for that site, okay? Now, kind of think about it. I just went through the different options. Where do you guys feel you stand? Or what have you seen? Okay, great. People are all answering here. And like I said, it can be application specific, depending on what you're planning. You might not need to be perfect, or you have to be perfect. Okay, great, thank you. I've got just a couple more people who need to vote. Okay, great. All right, and on this one, I'm going to go ahead and let me share the results just to kind of show where people are. So as you see here in front of you, here's what everyone said. 50% SSI 2, you know, it's good. The applications that we're running, they're correctly performed. Testing is, you know, it's done correctly. It's mostly on schedule. Equipment is replaced before an event. That is your average. That is usually what we see. It looks like on today's webinar that we do have a lot of people that pride themselves in performing everything correctly, near perfect perfection. You know, testing is always done correctly. It's on schedule. Equipment is replaced before end of life. That is also great to see. And then always, you do have people that this isn't that big of a factor for them. Now, is it right or wrong? That's up to the end user. That's how many failure rates are you able to allow? You know, how critical is it? You know, do you want to be an SSI 2? Do you want to be a 3 or a 4? You know, where is it that where are the areas that might need some work? Okay, and that's kind of where this SSI model comes in. And thank you for those who participated in that vote. That was great. All right, let's continue here. The impact. Now, when I speak about an SSI a site safety index, be wary because results in excellentia can vary by an entire SIL level when SSI is changed from perfect to good. All right, and it's not always, because if you build let's say you're building a real strong SIL 1 capable system, if it's real strong, even if you do have a lower than perfect index, say you are a 2 and index you put a 4, but you really should have been a 2. It won't change the SIL rating. However, if you have a SIL capable system and you just hit SIL 2, you just hit SIL 3, be careful because you could drop an entire SIL level if you do not follow the requirements you set. Okay, and that's something very important to know because people are building systems that may not be as accurately as they thought they were going to be. And that's one of the things that we need to make people realize. And that's the reason for today's webinar as well. Now let me show you in the current version of Excellentia, because I know many of you have this software. I'm going to show you where it is because it's currently called maintenance capability. SSI is something that we're putting into the new version of Excellentia. You're going to see it soon, but we wanted to get this webinar out sooner than later so more people know about it. Plus, I wanted to tell people where maintenance capability is. Okay. Now here's my Excellentia dashboard. Okay, we were doing a project this morning, but I just created a project named test just for this webinar here solely. So what you want to do is when you see the Excellentia dashboard, love this tool, makes everything so easy. I'm going to come over to Silver right here, and I can develop a system and up here, maintenance capability. This is now going to change to Site Safety Index, and here's where you're going to find the different ratings, whether it's an SSI 4, 3, 2, 1, or 0. Now, I did have a question that came in here, so I'm going to answer this one because it's very related to what we're working on. The question is, okay, I see these different levels, but what if we're somewhere in the middle? What if we're somewhere in between? Great question. And what I want to tell you is right now, we're creating a simplistic model to help take credit where it's deserved. As time goes on, this model will be perfected and it will be more exact. But as of right now, the demand is there. We had to create something, and we created this tool. Now, this tool has gone through so many reiterations, but we now have something that we can show people to take the credit. And so these are the latest we have. Yes, as technology and as time goes on, this will be perfected. We do have the operating hours to back up these ratings. We have over 200 billion operating hours that have been gathered over the last 30 years. And this is not something that could have been overnight. However, because we did our due diligence and because we're solely working in functional safety and spending all of our time and effort with this data and the failure rates, this is why we're able to produce such a tool. Okay, let me get back to our webinar here. I just want to show everyone where that was, so thank you for that. All right. So the model, we're going to talk about, now there's several factors that have been identified thus far which impact the Site Safety Index. Okay, and these include the quality. All right, this is all about the quality of the commission testing, your safety validation testing, your proof test procedures, the proof test documentation, your failure diagnostic and repair procedures, device useful life tracking, replacement process, SIS modification procedures, and of course SIS decommissioning procedures. And yes, there's many more, but I wanted to just list some of the top ones here. Okay. Now let's go into it a little bit more. There are two items that we've developed to allow someone to create a site safety index evaluation. And I know this was another question that came across. I knew I was going to get to it, and here it is. They asked, well, what are the ways that we can do a site safety index? How am I able to do this? What are the steps? Well, the first one is the best method, and that's to establish a ranking. What would happen is you'd have an experienced safety process engineer. He would do a site audit against an expanded version of IEC 61511. What he or she will be doing is they're going to be asking questions. They're going to review procedures. They're going to audit the documentation that's produced. And at the end of this audit, a score will result in a detailed report along with the recommendations for improvement will be given. All right, and this will be done on whichever sites you may think are perfect, you may think need work. It's really up to the customer or the end user as to where they'd like to see the evaluation performed on. Usually what we see, or we're seeing more and more, is they'll say, hey, look, I have a location here and here. Please visit these two facilities. We're really curious to see what you find. Because what they're finding is every site will tell you, oh, no, we're great. Oh, no, we're perfect. Don't worry about that. Yes, this is what we do. And it's fun to find and help solve some of the mysteries as to why some plants receive more failures than other plants. And that's what we can do. Another way, in my previous webinar, I put the webinar down there at the bottom, the link there. When you receive these, you can probably just click on it. If you can't find the link for the webinar, go ahead and email me or go ahead and go to the extra website under webinars. You'll find that's the link. That's the title of the webinar I did in October. And what that has, it has sample questions of the sample questionnaire that will provide you with initial results with less accuracy. So you can basically go to your plant, go to the site you want to do a site safety index on, and ask these questions personally and get your answers, and then that will help you produce one of these evaluations. Okay, and we can provide a comprehensive list as well. So, all right, let me continue here. So, how are these key factors impacted? Now, there's 5 categories in front of you that I'm going to kind of give an example for each one. All right, and how it is impacted by the site practices. Well, the first one we're going to talk about is the failure rates of each product. We're going to talk about actual proof test intervals, the actual proof test effectiveness, actual mean time to restore, and probability of initial failure. Yes, I could probably do a webinar on each one of these, but because of time, we're going to just kind of briefly touch on each one. When you have more questions, please feel free to reach out, because this is what we love to do. These are the questions we like to answer. The first one, failure rates are increased in lower SSI levels. Failure rates of each product, okay? So what does a FMETA predict? Well, the failure rates for a FMETA, when you receive this, here's the assumption. Products are installed in an environment that has been verified according to the manufacturer's specifications. Okay? Products are chosen with materials compatible with any process chemicals. And that's important because many people are buying products because of the seal capabilities. However, they're not checking if the materials are even capable with the system they're placing it in. And so that's something you need to keep in mind. You also have products, make sure that they're commissioned and calibrated according to the manufacturing instructions. Nobody likes, well, a lot of people kind of rush and need to build the systems to stay ahead of time and to not lose track, and they kind of skip the calibrating, or they'll skip the manufacturing instructions on how to set up their equipment. And because of this, they lose longevity of that product when they start seeing more failures. Now, in a lower SSI level, these activities may not be done well, which, like we just spoke about, will increase the probability of failure. And I know I had this on another slide, but I want to just reiterate the fact that field failure studies based on billions of unit operating hours at exit indicate that we are seeing a failure rate multiplication factor of between 1.2 and 2 between different sites. Proof test intervals increase All right. Now, in site surveys done by exida, it was apparent that proof tests were postponed in sites where a high level of operational discipline was not present. Actual proof test intervals are increased in lower SSI levels. Must stress the importance. If a manufacturer tells you, hey, you must do this proof test every month to maintain this SIL rating, be wary. Yeah, you can hit SIL 3 capable if you do this proof test every single month. Well, is that possible? Is that something you're able to do? What if you have to shut the plant down to perform this proof test? Could you do a partial proof test? What's allowed, what's not allowed? And what's happening is because people want these higher SIL ratings, they say, oh yeah, I can do that proof test. Well, guess what? A lot of sites are postponing these proof tests and they're not performing these tests as they should, which it results in a higher failure rate because they're not following directions. So realistic proof tests are so extremely important. I just kind of wanted to touch on that. The effectiveness. Now effectiveness will decrease, one, if your proof tests aren't done when they should be done. But what if the procedures of processes are not clear? And the test personnel, they don't have time to perform and document these testing. Once again, realistic proof tests, make sure your documentation is clean. I know it sounds easy and simple, but you'd be surprised how many people kind of look the other way when they have to do a task like this. So realistic proof tests are very important. Here's another one, your mean time to restore, okay? What's one thing to do your proof test, it's another. Well, what happens if something were to occur, maybe a spurious trip, maybe something failed, how quickly can you restore your system? Well, the mean time to restore may increase when a diagnostic procedure is not well documented or understood. MTTR will increase when proper tools are not readily available. Some restore effects will not be successful when personnel do not have sufficient time to inform and document results. Then what? A second effort is needed. Okay, and one thing that helps paint a picture is it's kind of a silly example, but it's very serious. What if you had a house fire? Obviously, the initial thing is right away. You know where the kids are. That's easy. So you know where the main safety functions are. You know where to push the button to stop operation. But what if, when leaving your room, you never clean your house and it's messy everywhere? You're tripping on things and you're trying to get to the main button to cease operation or even just anything. That's kind of like saying, well, I know what I'm supposed to do, but I can't read my documentation. It's all over the place. It's not in the right form. It's laid out incorrectly. I can't find my documentation. That's kind of like the same thing here. And then, okay, maybe you don't have that issue. Maybe you have the perfect documentation. You know where everything is. Well, what if you're going to use that plan moving forward to restore your system, and what happens? Boom, the hallway is blocked, and you don't have another path. Okay, what if the route that you wanted to do to restore your system all of a sudden fails, and you can't use that part of the process? Do you have any kind of redundancy to help get around any kind of blocks that you may pass when you want to restore your system? And these are some things to think about, because if you don't have things well documented, you haven't thought of any kind of redundancy, you may run into some risk. Okay, and yes, these are some small things. Will they happen? That is a big question mark. It all depends on if you follow the instructions from the beginning. You need to minimize risk wherever you can, and these small things aren't a big deal now, but in an emergency situation, these things will enhance. Probability of initial failure. Products used in a safety instrument function may not operate properly if if they haven't been installed or calibrated and tested during a complete commissioning process. When procedures are not clear and time is not available, probability of initial failure will increase. And I could have given this example in the last slide, but it's along the same lines here. Or you could say something like this: you buy a new sports car, and they tell you, look, you need to break this car in for 1,000 miles. Don't rev it over a certain RPM. You need to make sure the oil lubricates the motor. You got to make sure that it brakes in correctly. And why do they tell you that? Because they want the longevity of that vehicle. They want it to last the longest it possibly can. That's the same thing here. When people are going and they haven't installed something correctly, they're not calibrating things right away. They don't do a complete commissioning process. You're minimizing or you're maximizing the ability to create a failure. And things like this need to be taken serious to take into account. And mind you, all of these things that we're talking about, this is beyond getting a SIL rating of a certain level, SIL 1, 2, or 3. This is beyond that. You already bought the SIL 3 capable valve or pressure transmitter, I should say. You already bought that. But if you don't use it correctly, you basically can throw SIL out the window. It doesn't really matter what it's capable of if you're not following instructions. So just kind of a recap here. We did talk about the failure rates of each product. We talked about the actual proof test. We talked about the actual proof test intervals and effectiveness, the actual mean time to restore, and the probability of initial failure. And these are the items that people need to start looking at and making sure that their sites are completing these tasks correctly. And to recap, the Site Safety Index model, it's going to create a more realistic PFD average. You're going to get a more accurate result. Compared to simply adjusting failure rates, like we spoke about, some companies, they say, we know one site doesn't have much, so let's just be a little more pessimistic. Well, this approach allows a site with a strong safety process to take credit for that accomplishment while not masking issues at another site. It's going to show the impact of different operational policies. It could be used to show the benefit of improved operational processes. And of course, it can be used to justify improved operational processes. So if you need to say, hey, look, we need to do something here, and your boss says, well, why? Show me why. A site safety index is a way that you can say, look, according to this model, here's our area that we're lacking. Here's the area we can improve, and because we can improve here, this is how we can reduce our failure rates. All right. Now this is kind of concluding today's webinar, but I'd like to do one last poll just to see what people say. And I thank everybody for participating today, because we're going to do more and more of these polls because we're learning so much information from people that attend these webinars. So let me go ahead and launch it here. All right. Oh, excuse me. All right. So this question: do you feel that SSI would be useful in showing justification for better operational processes? Simple question, and I'm just trying to get a feel where everyone is about this topic. Great. Thank you. Thank you. All right. Just went on a couple more people here. Excellent. All right. Thank you so much for voting. I appreciate that. And like I thought, yeah, everyone basically say 90-something% do say that they see the benefit in the justification. And yes, we know that. And now it's just a way of spreading the word, telling people, and making sure that end users, or say even your operators that are working at these plants, the importance of what they're doing, that it truly matters. And that's what we're trying to get across to people. And now at this moment in time, I'm going to start answering some questions. Thank you for writing all these questions. Let me go ahead and see which ones I can answer here. All right. First question I have is, well, how did you develop this model? Okay, well, that's a good question. And like we stated previously, we do have over 200 billion operating hours of data that we can use. And because of this, that we've gathered this over the last 30 years, we're able to create such a tool. And without this information, these models would never have been produced. And as time goes on, these models will be refined to give even more credit where it's deserved. But currently, this is where the model lies. Already, companies are having huge success in finding ways to reduce failures. And it goes beyond, like I said, the SIL capability. So thank you for that question. Where can SSI be found? Well, currently, as far as I'm under the impression, Excellentia is the only place that actually takes into consideration proof or takes into consideration a reduction in failures after you already have your SIL rating. Because many certifying bodies, they stop, hey, I did my job, here's your SIL capability, good luck. We don't feel that's right. We think safety needs to go beyond just getting a SIL rating, because so many people now are, oh yeah, this is SIL certified. Well, are you using it correctly? Is your site set up correctly? And this is the next step that end users and large corporations are starting to use, is they're going through here and performing this, and that is why it's now in our tool. Maintenance capability was there from for a little while. However, with SSI switching into the maintenance capability and taking place of that, you're going to see the new parameters, and you'll now be able to take credit where it's deserved. How do environmental conditions factor in? Okay. Well, environmental conditions, they, believe it or not, in regards to the key variables that we spoke about, they play a small role. They don't really impact the failure rates here on planet Earth. However, unless we're speaking of process wetted parts in like specific chemistries, that's completely different. That will affect failure rates. However, in normal applications that most of you are from, like petrochemical, you're not you're not going to notice anything, any large impact. And if you do want more information as to the reasons there, please feel free to email me, and we'll take it from there. Okay, well, those were the questions for today. Thank you so much for everyone that attended. I know a few of you asked me for this white paper, so what I'll do is I'll go ahead and just send it out to everybody. Delete it if you don't want the white paper, but in the email, I will give you guys the white paper. I'll send you the answers to the questions that were given today. Enjoy them. Ask more questions if you'd like. Thank you so much, everybody. Have a great day. Thanks for attending. Take care.